All right, so that's what we had from last time, yes? All right, I'm going to go through these. Please make any adjustments that you need to on your paper to make sure you have it correctly done. So problem number 1, we have two linear equations. We have both of these. But they give us a ordered pair, and they want to know if that ordered pair is the solution. Okay? So what I'm going to do is I'm going to take that x and y value, and I'm going to plug into x and y on both of our equations and see what we get. So we'll do the top one in red. So I'm going to get 4 equals 2 times 3 minus 2. The 4 and the 3 were where y and x used to be. Do the arithmetic. And then I'm going to get 4 equals 4. That's a true statement. So that means this works on the red. And then let's use this other equation. We'll do it in purple. And we're going to plug in the same values. So then I got 4 equals negative 9 plus 11. So is 4 equal to 2? No. So this is not the solution. Okay, it has to work on both. Can't just work on one of them. Okay, so even though it worked on the red, it didn't work on the purple. So it's not going to be where the lines, if we had graphed them, that would cross each other. Okay, it is possible that these lines do indeed cross. It's just they don't cross at the same location as 3, 4. Okay. Problem number 2, same idea. And then I'll do this one here. 4x plus 2y is equal to 10. And they want to know, does the point 3 comma negative 2 work as the solution? So remember, that's an x and a y value. So we're going to plug into our x and y values on each. So I get negative 2 times 3. Negative 3 times negative 2 is that's equal to 12. We're in good shape. Oop, yep. So that's negative 6 plus 6 is negative 6 plus 6 equal to 12? No, not this week. All right. Friends, right now you could stop this problem because it did not work on the first one. So this is not a solution. Nope is a good old official word. I don't even have to try it on the other one. Okay? If it didn't work on the first one and it works on the second one, that's fine, but it still doesn't make it a solution. So we could, huh? Yeah, false, nope, not this time. Nope, something like that. All right, problem number 3. Y equals negative 2x minus 3, and y equals 2x plus 1. And they want to know, does the point 2 comma 3 work? So again, this is an x and a y value, so we're going to plug in our appropriate values into the right location. So I get 3 equals negative 4 minus 3. Is 3 equal to negative 7? That's not working, right? So, nope, doesn't work. Okay, and again, notice I didn't even plug it into the second one. I got a false statement originally. No reason to continue on with the problem. Any questions so far for me? Seem good? Okay, number 4. So we want to verify that the point 2 comma 3, if it works. So we're going to plug our x and y values. So I'm going to get 3 equals 2 times 2. What's 2 times 2?
4.
That's false. So not a solution, or nope. I don't even have to work. I don't have to go to the next problem. I mean, if you tried, you'd say, oh, okay, I get 2 plus 3 equals 3. 5 equals 3. Well, that's false as well.
Right.
Excuse me. Yeah.
On quizzes, do we have to do the other problem regardless, or can we just be like, oh, one's false?
Yep. If you showed me one's false, boom, stop right there. Save some time. Gives you more time to be on your phone.
Yeah.
Right? See? I'm looking out for you.
What are we thinking about the quiz? Just think about that.
What are we thinking about it?
Yeah, what are we thinking about next week?
This week is solving systems by graphing today and yesterday. Tomorrow is by substitution. Monday and Friday. No, substitution. It's a different method.
Not a substitute.
No, I plan on being here. And then Friday and Monday we have solve by elimination, which is a third method. And then we have a review on Tuesday, quiz on Wednesday. And then we start reviewing for the final on Thursday and Friday. And then after that, the week after that is finals. Yeah, baby. So you all realize once you have gotten done with the final, what days? This is third period. We have this, what day? The second day? First day?
No, it's the third day. It's Wednesday.
It's the Wednesday?
It's Wednesday.
So that means they don't have to come to this class on Monday or Tuesday? Does that mean I don't have to see Sid Monday and Tuesday of finals week? Man, I'm crying myself to sleep now I'm crying myself to sleep knowing I don't have to see Sid. That's not good. You guys swing by and say hello. Because I don't want to cry myself to sleep if I don't see you. I love you, Sid. You know that, bud. What'd I do? Yeah, Timon, your test is on that first day, isn't it? So you can tell all these guys the answer so they...
Oh my God.
I don't know. I don't know these things. All right. So first problem, I have a y-intercept at 2. Agree? Agree?
Yeah.
And then I have a slope of up 1, right 1. So this graph looks like this. Then my second graph, I have a y-intercept of what on my second graph? 2, so it's right there. So I'm going to go down 2, right 1. Hey friends, I might not be the best artist, but where do you think the solution to this problem would be? 0, 2. That's the solution. That's where they cross. Now, realize you will have grids, and I've been too lazy to pull up a grid. Sorry. I know I'm disappointing y'all. Maybe I'll pull up a grid on the next one. All right, let's see. We're going to try and do this without. Okay, all right, hang on. We're going to copy. Where's copy at? Oh, right there. That. Copy file. All right. Ooh, that'll work. Maybe this will work. We're going to find out. And we're going to paste. Edit. It didn't copy. All right. Copy. And paste. Paste. Ooh, it made it way too big. Oh boy. All right, ready? Problem number 6, yes? So I have y equals negative 3x plus 8. And I have y equals 1/2 x plus 1. What's the y-intercept of this first one? 8. So it's up here. What's my slope?
-3.
Yeah, so I'm going to go down 3, right 1. Doing the best I can with my straight edge. See if I can make that better. All right, that seems like a pretty good straight line. All right, let's try my other one. What's my y-intercept of this one? 1, so I'm going to go right up here to 1. My slope is 1 over 2, so up 1, right 2. All right. This looks like it crosses at 2, 2. That is our solution. Hey, so if you weren't sure if you had the right answer, what could you do with 2, 2 to verify? Yeah, you could plug it back in. You could say, oh, okay, so if I plug 2 in here, and negative 3 times 2 is negative 6 plus 8, so 2 equals 2. It works there. Then do the same thing here. 2 equals, what's half of 2? 1. Oh, sweet. We got it right. So, do you have to show that? Well, it depends what the problem asks. Okay, if it doesn't ask for it, then just graph it and give your best estimate. Okay? All right. Problem number 7. Problem number 7. Mason, thanks for coming in, bub.
I would just like, as a person who's not always drawing like a super straight line, even with a ruler, I would still just double check it. It's a quick double check. If you're not super straight on your arrows, I just would get in the habit of double checking with this point. Okay, that's just what I would do.
Hey, how's number 7 set up to graph? X and Y are on the same side, so it's the cover method. So 0, comma, blank, blank, comma, 0. Okay, so this is my X value. So 4 times what number gives me 12? 3. So 0, comma, 3 is up here. So that's our y-intercept in this case. This is my y value. So 3 times what number gives me 12? 4. So 4, comma, 0. All right. Oh, got to adjust it. Stuart made a boob. Boo boo. That looks pretty good. All right. And then this one is set up. I know my y-intercept is 2. And my slope is down 1, right 2. Ooh, hang on. Down 1, right 2. Ooh, right there. See how I did that? I used my slope twice. So that appears that they are crossing at 4, comma 0. And again, you could double check this. Just make sure if this works. This is the solution. But if you realize that's an x and a y value, let's see. 3 times 4 is 12. 4 times 0 is 0. Is 12 plus 0 12? Yeah, it works there. Try the same thing over here. I get a 0 for the y. Half of 4 is 2, so negative half of 4 is negative 2. Hey, that works as well. Cool. We did it right. Oh, boy. Hotcakes and sausage. Friends. Yeah, you're missing out. Yeah. Pancakes, yeah, buddy. Mmm. And then you dip the sausage into your syrup. Oh, son. Life is good.
You don't like sausage? Never had sausage.
You're missing out.
You like turkey sausage? No.
I eat the plant-based sausage. It's pretty good. It's made out of soy. Right. All right. All right, here we go. So I know I did not give the back page, but we're going to go through and we're going to hit the even numbers on the back page. You with me on this adventure?
Yes.
All right, so copy down the even ones that we do. Sound good? All right, so problem number 8. What's my y-intercept of this first one?
-1.
Very good, -1. What's my slope?
3 over 1.
3 over 1. So I'm going to go up 1, 2, 3, right 1. Do the best I can with my straight edge. Ooh, I got lucky on the first shot. All right. Hey, how's this one set up to do? How's that one set up to do? Cover method. Now, this is definitely a cover method that would work. So 0, comma, blank, blank, comma, 0. I think we might get a fraction, but that's okay. Fractions exist in math. All right. So this is an x value. So that means that negative 3y equals 10. So y equals negative 10 thirds, which as a mixed number is negative 3 1/3. And I'm just writing it as a mixed number so we can see it a little better. So negative 10 thirds. So 0, negative 10 thirds. So negative 3 1/3 is like down here. Is that okay so far?
Yes.
All right, that's a y value. So that means 2x equals 10. So x equals 5. So we're there. Now, this is a perfect reason why graphing isn't always best. Okay? But with my straight edge, I think I might have gotten lucky and found that point right there to be negative 2, comma, negative 5. Ooh, I don't know if that works. Maybe it does. Negative 2, negative 5. Let's plug it in, see what happens. So I get negative 5 equals 3 times negative 2 minus 1. Talk to me, friends. What does this mean?
It's wrong.
Yeah, but I feel like I graphed it pretty good. No. They're definitely crossing each other. But my graph is maybe off a little bit, right? So this is why when we get to tomorrow and tomorrow will be the same lesson on Thursday and then Friday and Monday. There are different ways to work these out that your answer will work. Okay? I mean, I think we've done almost everything correctly. Now, it's possible this should be maybe negative 1, comma, negative 5. It might be negative 2, negative 6. It might be negative 1, negative 6. I don't know. I might have made a mistake. Okay? But do you see how the mistake took place? Okay? We graphed it by hand, and we might have made a little bit of an error on it. Is that possible to do? Yeah. So that's why it's a good idea if we double check it. If I take negative 2, negative 5, plug it into the other equation, I'm going to get negative 4 plus 15, which is 11. Is 11 equal to 10? No. So that appears to be our solution based on our graph, but we can verify it is not our solution because when we plug it in, it didn't work. Okay? So I'm cautiously telling you that for a reason. Okay, now it is possible we might have graphed it totally wrong, so we might go back and double check. Let's see, I have y-intercept negative 1, up 3, right 1. First line looks good. Cover method, 0, negative 10 thirds. Yeah, I think we're pretty close to negative 3 1/3. And then 5, 0. Yeah, we're pretty close, but it's just that because we're humans, that sometimes graphically it is sometimes fun to do, but we might make a mistake. Does that make sense? So this is good. Hi, you got a Starbucks gift card for somebody? We'll call it that.
Yeah, sure.
All right, let's see.
There's 2 of them.
Gotcha and gotcha. Cool, they're both here.
Mr. Sir,
Not you.
the coordination is negative 1 over comma negative 4.
What is it?
The number 8.
It's negative 2, negative 4?
Negative 1 comma negative 4.
Ooh, negative 1 comma negative 4. Okay. So you graphed better than me. Or you just kind of went through and figured out regions around it. I like it. Oh, you did great. I like it. So it was said that this was actually the solution. Hey, friends, how close is this point to this point in the grand scheme of math. They're pretty close. I mean, -1, -4, -1, -4 is like right here. I mean, that's really close. Okay? But there might be some times that errors take place, especially if you're not using a straight edge. Okay? I'm projecting up on a big old board. I'm not perfect. Never said I was. Yeah. Yep. It would. Yep. You're right. Yeah. It's just my graphing was off a little bit. Okay. So I probably would. My graphs are probably right. I probably just have to adjust my lines a little bit. But like if I adjusted this one a little bit. Yeah, look at that. Look at that. That right there. Yeah, that works. That works. Okay, moving on. Let's take a look at problem number 10. Problem number 10. All right. How's this first one set up to graph? How's that first one set up to graph? Cover method. So 0, comma, blank, blank, comma, 0. Hey, what goes in right away on the blanks? Yeah, I got 0, 5, and 5, 0. So 0, 5 is up here. 5, 0 is here. Let's see if Stirrup can make better. There we go. That's kind of sort of okay. And then the second equation is set up to what? What do I know? It's up 3, y-intercept. Down 1, right 1. Now I'm going to keep following. It's down 1, right 1. Down 1, right 1. Down 1, right 1. Hey, what does this look like? Yeah, they look parallel. Hey, parallel lines have what for a solution? Do they cross?
No, so infinite.
Nope.
Or no solution.
So these are parallel. So they won't cross. So no solution. If it was the exact same line lying on top of itself, it would be infinite solutions. So I don't know if we'll come across it. Maybe we will. I don't know. All right. What do you think? You doing all right? All right, let's take a look at number 12. Number 12, we have 3x minus 4y equals 12, and we have y equals 2x plus 2. How is this first one set up to do? Cover method, so 0, comma, blank, blank, comma, 0. So that's an x value, so -4y equals 12, so that I think is -3, so 0, -3 is down here. And then this is a y value, so that's going to give me 3x equals 12. So 3 times 4, so 4 comma 0. All right, that's that line. Second one is set up to graph a y-intercept of 2 and a slope of up 2, right 1. Ooh, up 2, right 1. Let's see. That looks like it could be the solution. All right. That point right there appears to be -2, comma, -5, but Stirrup might make errors, right? That might be the solution. Let's plug it in. So 3 times -2 is -6. -4 times -5 is +20. Oop, +20, excuse me. Ooh, shoot. Stirrup made another error.
This must be 2 on the like positive 2 should be right.
Do what? Oh, you're right. Holy moly, guacamole. Dude, can't take Stirrup anywhere. Stirrup can't even graph these right.
What, holy guacamole?
Wow. No.
All right, so my y-intercept was positive 2. Boy, oh boy, oh boy. All right, then up 2, right 1. What'd you learn in Stirrup's class today? Something about guacamole, but I don't know.
See, I think it's -6 and -9.
Negative 5x, negative 6y.
What do you guys think it is?
Negative 5x, negative 6y.
So -6, and then if I come down, -8? I don't know.
Mine says -6, -9.
-6, -9? Oh, I don't even know. Holy cow. All right, that's -18. That's positive 32. I'm still off. Jeez.
Negative 4, comma negative 6.
-4, kind of -6. Let's see if that works. I bet you're right. I'll tell you, I'm glad I'm amongst bright people. Let's see. That's -12 plus 24. That is 12. Good. That works on the first one. Looking at the second one. -6 equals -8 plus 2. Oh, you nailed it. That is the solution. Good job. You guys are, I was told a long time ago, if I surround myself with the smartest people, I'll actually look pretty bright. So I'm amongst the smartest people, so I'm looking pretty bright these days.
Yeah,
That's true. So what should you choose to hang out with?
Me.
The smart people.
I should not.
All right. All right, so let's take a look at 14, 15, and 16. 14, 15, and 16. We'll do all these. So y equals 2x, y equals 2x minus 5. Hey, friends, what can you tell me about these two lines? What's the
same slope.
They have the same slope. Are they the same equation, though? No, they're not the same equation, but they have the same slope. So same slope, but different equations means they're parallel. So parallel has how many solutions? 0 solutions. So all I did was looked at was the slope. I have a slope of 2, I have a slope of 2. They're the same, but they're not the same equation because one of them has -5, one of them doesn't have anything. So they're parallel. All right. Let's take a look at this number, 15. Now, I don't have a graph on this one. What's the slope of this first one? -1. Now, I'm going to modify this. I'm going to go subtract x. So I get y equals -x plus 4. Hey, friends, what does this look like in comparison to this? Same thing. So this is the same line. So how many solutions? Yeah. And you are graded on if you can make an infinite sign.
Are you serious?
Yep.
right now?
Yep. There you go. See, again, I surround myself with the smartest people, and I look somewhat bright. Yeah, I do.
No.
I think you're very smart, kiddo.
That's a lie.
All right. So last one, y equals -3x plus 1. Y equals 2x plus 7. Hey, do I know the slopes of both of these? Yeah, I know this has a slope of -3. This has a slope of 2. I have two different slopes. I guarantee these lines will cross each other. So if they will cross each other, how many solutions do we guarantee to have? We have one solution. We have one solution. We have some xy value that will work. Okay? Friends, how do we feel? We're good in the hood? All right, my friends. For tomorrow, I would like you to do page 201 and 202 all.
No.
And some of you have discovered there's no 202. So it looks like I gave you a lot of work, but I only gave you one page.
Still, it's a lot of work.
You can handle it. Do well. Make us proud.
No.